Alright, for today's lesson, we were talking about rational functions. You guys are going to need to take your own notes, and I'll go through and just underline things as we go. So again, rational functions are a fraction type function where there's an x on the top and an x on the bottom. So it's a polynomial over a polynomial. To graph these, we need two things and two sentences. The two things we need are intercepts and asymptotes, and the two sentences are these guys are functions and graphs hug asymptotes. So we're going to go through and figure out what all this means. Let's start with y-intercepts. Where did my thing go? Oh my gosh. On there? First thing we need to find is y-intercepts. I want you to put a title on your page that says y-intercepts. Now guys, we've been talking about y-intercepts for years. The y-intercept is where the graph crosses the y-axis. How do you find a y-intercept value? You plug in x equals 0. So we set x equal to 0. That's all we do. So we're going to use the same example that you wrote down at the top of your page for every single part that we're going through today. So the example, it might be a good idea if you just kind of go to the bottom half of your page and write out this example. So when I plug in 0 for my x's, we end up just with the minus 6 divided by the minus 1, which gives me a y-intercept at positive 6. So again, the y-intercept is at 0 and 6. Now let's try the x-intercept. So the x-intercept is going to be your next title. To find the x-intercept, that's where the graph crosses the x-axis. Same thing as finding the zeros or solving. So when we find an x-intercept, now what do we set equal to 0? Y, right. So when you're finding an x-intercept, you set y equal to 0, or f of x equal to 0, and solve. Now, again, same example as before. We're now going to find the x-intercept. So when you find the x-intercept, we put 0 into the y position, and we get x squared minus x minus 6 over x squared minus 1. Now, how can I get that bottom out?
Times it out.
Multiply it. Yeah, when I multiply it out, it's multiplied by 0. And anytime you multiply something by 0, you get 0. Yes. So all we're actually left with is x squared minus x minus 6. Again, because the denominator has been multiplied out by 0, so you have x squared minus x minus 6. Then we have to go through and we have to factor, because I see that I have a quadratic. So two numbers that add to minus 1 and multiply to minus 6 are going to be x minus 3 and x plus 2, which give me the solution of x equals 3 or x equals negative 2. So here I have two x-intercepts. Okay, now let's take a look at asymptotes. So I'd like you to write asymptote and then this little sentence behind it, that graphs hug asymptotes. So again, what that means is that your graph is going to curve toward your asymptote lines and get really, really close. Okay? Graphs hug asymptotes. Now I'd also like us to take a look at our base rational function. So I'd like us all to please draw this, because this is our base rational function where you have a 1 on top and an x on the bottom. This is as simple a rational function as you can get. So take a minute please and draw this. So remember that asymptotes are lines that are usually invisible, where a graph gets closer and closer to but never touches. So let's make our next title vertical asymptotes. Okay, there's two kinds, vertical and horizontal. For a vertical asymptote, you set the denominator equal to 0 and solve. And remember that that's because we can't divide by 0. So we represent that with an asymptote to say that we can't be there, because we can't be at dividing by 0. So if you set the denominator equal to 0, that gives you x squared minus 1 equals 0, and then you will factor, and get two different vertical asymptotes at -1 and 1. If you draw it on your graph, it would look something like this. Two dashed lines, one through 1 and the other through -1. So it looks something like that. So now let's look at horizontal asymptotes. So a horizontal asymptote has three different options that go along with it. To decide which option you're given, you're going to look at the highest power in the top and the highest power in the bottom. Now, a horizontal asymptote, again, what's really happening is we're actually dividing these things out. So if the top is smaller than the bottom, for example, that would be like 3x over x squared, x does not can't be divided by x squared, so we just say the x-axis is the horizontal asymptote, or it's at y equals 0. Case 2 is where the powers are the same, so that's like 3x squared divided by x squared. Now if that's the case, your x squareds would cancel, so you'd just be left with the leading coefficients for your horizontal asymptote. So again, you're just looking at your front numbers and you would divide them to get your horizontal asymptote for case 2. For case 3, this is where the top degree is bigger than the bottom degree. So that'd be like 3x cubed over x squared. When you divide that out, you'd just be left with 3x. So if the top is bigger than the bottom, there's no horizontal asymptote. Your asymptote you're left with is either going to be a slant, which means a straight line, but it's at a slope, or an oblique, which basically means it is a parabolic or a parabola shape asymptote. So those are our three cases. Make sure you write those down. You're going to need to know those. So we're going to try one here that's case 3. Case 3, again, the top is bigger than the bottom degree, so we actually have to divide these. So when we divide these, we're going to use synthetic division. Synthetic division means we're going to take the numbers from the numerator and put them in the top. So 5 is my first coefficient, minus 3 is the second coefficient, and 1 is the last coefficient. Now, this synthetic division is fairly simple because we only have one factor in the bottom. So I'm going to divide by the factor of x plus 2, but what makes x plus 2 equal to 0? -2. So I'm going to put a -2 in front because that's what would make x plus 2 equal 0. Now in synthetic division, you start by bringing down your first number. So I'm going to bring down the 5, and then we multiply going across. So minus 2 times 5 is minus 10. And then we add coming down. So minus 3 and minus 10 is minus 13. Then again, I multiply going across. So minus 2 times minus 13 is positive 26. And again, we add coming down to get 27. Now remember, the last thing that you get is going to be your remainder. And the remainder happens when the numbers you're dividing don't work perfectly. And that's okay. It's okay to have remainders with what we're doing right now. But what do the other numbers tell me? The other numbers are the equation of the slant asymptote. So we get y equals 5x minus 13. So again, you look at how many numbers you have. The last number here is your constant. And then you just go up 1x at a time. So we're up to x to the power of 1. So 5x minus 13 is our slant asymptote.
Yeah.